All right, in this video, we want to find the Laplace transform by using a table of transforms. And this table is coming from Theorem 4.1.1 on page 215 in the textbook. And we're given the function as f of t is equal to 6t squared plus 3 cosine of 5t. So remember that the Laplace transform is linear. So basically, instead of writing like the Laplace of this entire function, we can basically just kind of like how we found when we broke up the integral in those earlier two examples where we're using the definition of the Laplace transform. We can break apart each individual term. So we can do Laplace of 6t squared plus Laplace of 3 cosine of 5t. And that would actually just be the same thing as the Laplace of both added together. And we can take it a step further using the property of linearity by pulling all the constants out. We also saw that in one of the examples where we pulled the constants all the way in the front of the integral. And this is the same thing. We can pull the constants in front of the Laplace transform. And that helps because we can just, notice here we're just solving the Laplace of t squared. We're just solving the Laplace of cosine of 5t. These are simpler functions that are a bit easier to work with. So step one is we're just going to apply one of the equations in the table that we're given. So notice how the first Laplace transform, we want to find Laplace of t squared. So we're going to, first of all, recall that 6 is outside of the Laplace transform, so we don't have to worry about that. And we're using the table. So we have, for t squared, we have a equation where we have n factorial over s raised to the n plus 1. We identify that n is equal to 2, and so we just plug in everything here. We simplify it, and we get 12 over s cubed. And for 3 times the Laplace of cosine of 5t here, in a similar fashion, we're given one of the equations in the table where we have s over s squared plus k squared is the Laplace of cosine of kt, right? In our case, k is equal to 5. And so we're going to end up with 3 times s over s squared plus 5 squared, and that simplifies to 3s over s squared plus 25. And step 3 is just simply combining the results of steps 1 and 2. 12 over s cubed plus 3s over s squared plus 25. So that is significantly easier than applying the definition of the Laplace transform, and that's why we're given the table, because we can quickly find the Laplace transforms of functions without having to, perform all the integration.